So if you said exponential, you were correct, because this is a function that returns a positive number for every input. E to the x is always a positive number. So what we're going to do is exactly what we did before, except applying e to the x to the scores. So instead of 2, 1, 0, we have e to the 2, e to the 1, and e to the 0. So the 2 becomes e to the 2 divided by e to the 2 plus e to the 1 plus e to the 0. And similarly for 1 and 0. So the probabilities we obtain now are 0.67, 0.24, and 0.09. This clearly add to 1, and also notice that since the exponential function is increasing, then the duck has a higher probability than the beaver, and this one has a higher probability than the walrus. This function is called the softmax function, and it's defined formally like this. Let's say we have n classes and a linear model that gives us the following scores: z1, z2 up to zn, each score for each of the classes. What we do to turn them into probabilities is to say the probability that the object is in class I is going to be e to the power of zi divided by the sum of e to the power of c1 plus all the way to e to the power of zn. That's how we turn scores into probabilities. So here's a question for you. When we had 2 classes, we applied the sigmoid function to the scores. Now that we have more classes, we apply the softmax function to the scores. The question is the softmax function for n equals 2 the same as the sigmoid function? I'll let you think about it. The answer is actually yes, but it's not super trivial why, and it's a nice thing to remember.